Hello there. Thought we'd make up a quick video to show people how to use PIIDigger. So that's what we're going to do. So you can see here we are on our Kirkpatrick Price GitHub site. So that's just github.com/KirkpatrickPrice. And then we got a number of tools up there. One of them right here, PIIDigger. This is the one we're going to want. So we'll go ahead and head on in there to that page. And as soon as GitHub gets around to it here, there we go. This is where the official site for PIIDigger will always be. So you can always come here to get the latest version. We do maintain that fairly regularly. So be sure to check back if it's been a while since you ran it. Be sure to come here and get the latest release. What we want to do is we want to scroll down. There's a whole bunch of information on here. This is all very useful information, but basically we're going to cover what's in here. We're going to cover in this video today. What we want to do is see this section right here about binary packages. Okay. So we do have OS specific at this point. We have Linux and Windows binary packages ready to go. We'll be providing Mac OS binaries at a later date. If you need to run this on Mac OS, you can also use this installing from pip method that's listed here. We'll cover that in a different video though. All right, so we can go straight to the releases page. You'll also see that the releases page is right up here. Currently, the current release is version 1.13. Like I said, keep checking back regularly to see if a new version has been posted. We also give you the SHA-256 hashes for each of the Windows and Linux versions there. Every version that's published, we'll provide the SHA hashes there for you as well. What we want to do is just go ahead and download this Windows version right here. So let's save that. We're going to drop that just into a downloads, just someplace that we can work on it. Doesn't matter where you put it, it'll run from anywhere. So we'll go ahead and save that. See, we've got that saved. Let's open that folder, and you can see we've got a Windows version right here. Let's just go ahead and extract that. And so there, now we've got a version, or we've got a folder called Windows, and that is where it is at right there. So let's go ahead and head in there. The easiest way to run it is just to run it. And as long as you don't have to make any special changes or anything like that, this will run totally fine without any other configuration or anything. Just make sure that you do have both the internal as well as the PIIDigger executable content. If you put this on a network drive or make it available to other users, both of these have to be in the same folder, just like you see it right here. So let's just go ahead and run PIIDigger. Now, on different operating systems, you may get, or different antivirus, you may get this warning. And this is just Windows Defender antivirus telling us, hey, I don't know what this file is. You sure you want to run it? We do want to run it. And you can see here we do sign this, and it is signed as coming from us, from Kirkpatrick Price. So you can validate that, and then you can just go ahead and run anyways. And you can see it's just going to run. So let's just show what it's doing right here. It's going to, by default, it's going to scan everything on the C drive, and it's going to look for primary account number, credit card data, in other words. By default, it is going to take as much of the CPU as it can get. This is a very CPU intensive, as it's opening up all these files, reading them, and looking for the interesting types of data. In this case, primary account number as the current data types that are supported in PIIDigger. And so it's scanning for all the file folders first, and as it finds them, and this is multi-threaded, multi-process application, so like I said, it's going to take up as much CPU as it can, and I'll show you later on in the video how to reduce the CPU impact, especially if you need to run this on a production server or something. So it's identifying all the folders, and it's still counting them. You can see this total number of folders is going up. At the same time as it finds a new folder, it's going to scan that folder and look for interesting files by both MIME type as well as by file extension. And then as it finds interesting files, it's going to give them off to be scanned. And you can see it's also scanning and doing a pretty good job of keeping up. And then it's also counting the results. And so this is just the status update that you're going to get while PIIDigger is running, right up until the time that it's done. And so with that, let's just go ahead and stop it early here. We can just hit Control-C as shown right here. If needed, Control-C. And there, now it's done. So what do we have? We have a couple of new folders in this place where we ran it from, and these folders will by default be created in whatever place you run PIIDigger from, in whatever folder. And so we have a logs folder, probably not going to need that unless there's something, maybe you need to see, maybe there's some troubleshooting we need to do. I might ask you to create a log file and send me that. But that's really about the only time that we'll use what's in the logs folder. The PIIDigger results probably more interesting, so let's just take a look. And you can see we have both a JSON file as well as more, like to be consumed by some other, application or something that can read and use that JSON file. JSON is just a text format, but probably more interesting to us is going to be this this results.txt file. Okay, and you can see the name of the file is going to be the name of the device, the system name, followed by the date, followed by the timestamp that you ran it. And so that's so every time you run it, you'll get a new set of results by default. And so you can see it found some things in the recycle bin. So it did jump in there. You can see this is probably from me just doing a bunch of testing and things, because this is going to be one of those Python files, .py. And you can see we've also got some other deleted files that have been removed, all in the recycle bin again. Example files. This is all part of just the PIIDigger source code repository that you can see on GitHub. But that is a demonstration that is working, and we can see this. It found primary account number, specifically an Amex number, and then this redaction is applied by the application, by PIIDigger itself. But that should help you go find and confirm that this is a positive result, as a true positive instead of a false positive. And so that's just basically the layout. As we bring new features to PIIDigger, we might find that phone numbers might be listed, or email addresses in addition to credit card numbers, because those are all on the roadmap for as we continue to develop PIIDigger. And so again, that's just going to be the layout of the results file. Real quick, we'll just go take a look at this JSON file. You see that it's the exact same information. It's just presented in a JSON format. So if you have another process that you'd like to import these results into, JSON is a standard data format that you can use to, and so that is just one of the two current types. There's also designed to implement an Excel spreadsheet and maybe some other types of data output for the results. Okay, so let's go ahead and close that down. Let's come back here to our Windows folder, and that is just going to work in almost all the cases. Okay, but especially if you just need to run this one off and you're going to have some other capability, or you're going to and you just need to use the default configuration. Okay, so now let's show some more advanced configurations for PIIDigger. And so for that, we're going to go to a PowerShell session. And you can see I'm in it. I've currently got a PowerShell window already open, and we're in that downloads temp folder where we downloaded and placed the PIIDigger program itself. So let's go into the Windows directory, and then we'll see we got our PIIDigger logs and PIIDigger results in the PIIDigger program files itself. Let's run PIIDigger.exe with the help option. So /help. And you can see there's a number of different options, command line options that we have. I'm going to point out a couple of them in just a minute. We're going to create a configuration file so that we can override the defaults. And then I'll also show you in a bit later, we'll show you how to do some performance tuning. Mostly that means slowing it down so it doesn't take up the whole CPU. And we're going to use the -P for that to identify the number of working processes that we want to have. Okay, so let's, and then there's a couple other interesting bits down here: CPU count, list the data handlers, list the file types. These are just informational. And as well the version, right? These are just informational items. Feel free to play around with those on your own. But let's go ahead and create a configuration file. Now notice down here that we've got this bit right here. The default configuration file is called PIIDigger.toml, T-O-M-L. TOML is just a popular, very easy configuration file format. I chose that so that it would be easy to work with, and you'll see just how easy it is here in just a minute. If you're familiar with back in the day, the old .ini files in Windows, and prior, back when Windows was Windows that ran on top of DOS, like you'll recognize those in the old ini, and if you're a Linux guy, you'll recognize the ini format, and TOML is very similar to that. If we name our configuration file PIIDigger.toml, then the program will just pick it up by default. It'll just use that instead of its built-in default configuration. So let's do PIIDigger.exe C to create -C to create a configuration file. We see that right here, right? And then we're going to create one called PIIDigger.toml. And there it says, hey, we created our default configuration. So now let's open that PIIDigger.toml up. And let's see what's in it. Okay, so again, very easy to work with. Okay, data handlers right now, it's just going to look for primary account numbers, credit card data, because that's the only thing that PIIDigger can do. But as we add more capabilities, you'll see those added in here, and you can override that. If you only want to look for phone numbers at a future date, then you can only look for phone numbers. If you only want to look for credit card numbers or social security numbers or something like that, then you can specify those too. But by default, it's going to look for everything that it can. This local files only, this is a setting that is useful for Dropbox and OneDrive implementations on Windows, and that will avoid downloading. When this is set local files only, set it to true, it will check first to see if that file is already local on the hard drive. And if it is local, then it will scan it. But if it is not local, then it will just skip it so that you don't have to download everything off of OneDrive and fill up your disk or something like that, right? So you probably want to leave that to true, but feel free to set it to false if that's your use case, right? Results, this should be pretty self-explanatory. This is where the results are going to be sent. So if you're going to run this across dozens of computers, maybe you have a network drive or a shared something that you can, and you want to specify that in here as well. So you could override this and put a full path in there, and it will write them all of the files for all of the computers into that shared location. And so that's where that naming convention that's used is going to be helpful, because it's going to use the system name, the workstation, the server, etc., name dash the date string, the full date, year, month, day, and then the timestamp. So you can write them all into one folder, a shared network drive, for instance, and that will and they won't step on each other. And so that might be helpful in your case as well. And then include files. By default, we're going to look for all files, all file extensions, and all supported MIME types. And so you can use this. You can see this here in the background. This list file types that will tell you what the MIME types and the file extensions are that are currently supported by PIIDigger. So if you only want to search for certain types of files, you can specify those in there as well. But by default, it's going to do all. And so then this is probably the first place that you'll end up making some sort of a change. You can specify, you can see here, for instance, Linux and Mac OS is referenced as Darwin because that was its internal project name years and years ago. Those are going to scan the full file system starting at the root. And for Windows, we're going to scan all available drive letters. Okay, and so that doesn't matter whether it's a Google Drive mounted, with drive letter G, or whether it's a USB thumb drive, or whether it's a network drive. If it's available, or a CD, if you happen to have an old ancient system that still has a CD in it, and you actually put a CD in the drive, then it's going to scan that CD, right? Or that DVD, right? And so the first thing that you might end up doing is specifying some other, and you can specify anything that qualifies as a path here, right? So let's make this, and it has to be a list, and a list is denoted as square brackets, right? And then inside the list, we're going to have some strings specified, and this is TOML formatting, TOML formatting, right? And so this has to be inside double quotes for strings, and we can just specify a direct path. Now notice I'm putting double backslashes. This is also a TOML convention, and so that double backslash ends up getting condensed down as TOML parses this file into just a single backslash that you would expect in a Windows path. But you do need to put the 2 backslashes in there because otherwise backslash has a specific meaning in TOML. And so we're just going to specify my PIIDigger test folder so that we can let this actually run through without having tens of thousands of files that need to be scanned. And so you can specify a full path, or if you just want to specify, in addition to that path, you can also specify the entire D drive. Okay, you can. Anything that qualifies as a Windows path, you can put in here. Just make them a comma-separated list as strings inside quotes, right? And it'll work. And if you end up getting the format wrong, PIIDigger will tell you, hey, I have a format error in your TOML file, and it'll let you know where that's at, so you can go fix it. So let's just do this, and we're going to leave the rest of these alone because we're only running it on Windows right now. Okay, and then down here under excluders, this is another place that you can also get more specific. So for instance, if you did want to scan all drive letters, you would leave it the way that it was before, but you could also down here, if you didn't want to scan some drive letter that might be mapped to a network drive, the user's home directory, for instance, or the end drive, whatever the drive letter is. If you didn't want to scan those, you can add those in here as excluded paths. And again, don't forget the double backslash. But other than that, just specify Windows paths or whatever the operating system specific pathing format is, and you can exclude specific. And you can see we have a number of excludes for operating system related stuff on both Linux and Mac OS. Chances of finding PII in these places where by convention there's only binaries, there's only program files in these paths. Chances that we're going to find PII in there is very small. But you can, again, the full configuration is available to you. Okay, so we can specify these in here. The only other thing that we might do at some point in the future, if you end up having a problem with PIIDigger and it didn't work correctly for you, is I might have you change this from info to debug and then send me the debug file. And in that case, it's going to make a much bigger file, but you're probably going to leave that alone unless I tell you to send me a debug file. Feel free to turn it on, see how much information is in there. There's a lot, right? Okay, so what we did was we changed our starting path that we're gonna start from. and we added an exclusion that really isn't going to get used in this configuration because this H drive exclusion, like we could, it would only be valid if we were scanning all of the drive letters, right? But we're going to leave that in there because it's valid, right? So, okay, so let's I just save that. And so now let's run PIIDigger again. Okay, and this time we'll see that it is going to, let's see. Oh, I actually did get a, I actually screwed up my own configuration file. And so it says here that we have an unescaped string at line 15, column 24. So let's see if we can go find that. Line, and so I bet, yep, it's right here. I didn't get my full double backslash in there. So line 15 is just about where it is. I could spot the error there. So so now let's try it again. There you go. Now it's working. Okay. And so, and you can see, we can tell it's working because it's instead of scanning from the entire C drive, it's now scanning only that file path. And you can see that it's just crunching through this. It found 568 folders, which is about right. And it is cranking through those pretty good, 200, about halfway through them right now. And so we're just going to let that run while we continue to talk about some things here. And so the next thing that we'll do is I'll show you how to do some performance tuning, and you'll see that with the -P option. We'll just go ahead and refresh memory on that before we actually do that here. -P, and we will also use a CPU count so that we can determine how many CPUs are being reported to the operating system. Okay, in the meantime, we can see that it finished, and it found 33 results. It's going to be all in that test data that we saw in the first run, but in that case, we saw it in the recycle bin. Now it's going to actually be real test data. Let's just go have a look. So let's just use the PowerShell command, get content, PIIDigger results, and let's just. This is going to be our second set of results here. And you can see, in this case, we have full paths instead of stuff that's inside the recycle bin. And so again, but we found actual results, right? Okay, let's clear the screen. And so now let's do PIIDigger. And in this case, let's get the help back up there again. And so let's first use the CPU count, and we'll talk through what that actually is here in just a second. So CPU count, it says, hey, I think there's 8 cores. That's what Python sees. All this program is written in Python, and then we compiled it to an executable for you. But it says, hey, I see 8 cores. Now what that really is this is an Intel hyper-threaded i7. And it has 4 physical cores, and with hyper-threading, it makes it look like each core is really 2 cores to the operating system. So that's how we got to 8. There's a whole page that talks about performance tuning back on the GitHub site, and it talks about the effect of hyper-threading, etc. Now, if you're running on a non-Intel processor, then your CPU count will vary, and the effect of that CPU count, it might actually be more like the simulated second set of cores in hyper-threading, or it might be something else. But do take a look at that. And so at that page, and it's called Performance, and you'll see it linked off of the main page for PIIDigger. But what we want to do is we want to leave plenty of room so that other processes on our production server can actually get the work done. So the minimum number of processes that you can run is 1. So we're just going to do that. So PIIDigger, in this case, we're going to use -P followed by a 1. This is as slow as we can make PIIDigger. It's only going to use one file handler process to do all the really hard work. Now that's going to make it take a lot longer, but we will also see that our CPU is going to be much better behaved. Okay, and so we see here confirming it's using one file scanner process and one file handler process. So this is as slow as we can make it run. Other than that, we're using the exact same configuration. The number of processes, we can only really set that right now at the actual runtime on the command line. And so there you go. In about 23 seconds, it finished a scan, and it still found those same 33 results. Okay. So that is some performance tuning, creating your own configuration file, running PIIDigger from its default configuration, and then also looking at the results. And so I think that's everything that we wanted to cover in how to use PIIDigger. Of course, if you have any questions, feel free to reach out to me. You can contact me through GitHub. And you can send me a message through there, and I'll be sure to try to get back to you as quickly as I can. Take care and happy digging.